All right, so we're almost done, chapter 2, and today we're going to talk about elements and compounds. So here's the goals that you should know after the end of this video. Obviously, as the title would suggest, we want to be able to distinguish the difference between elements and compounds, distinguish between element symbols and the formulas of a chemical compound, and distinguish between atoms and molecules, okay? So here we go. So we're going to use silver as a representation of one of two kinds of pure substances. And like all pure substances, silver has its own unique set of physical and chemical properties that differ from the properties of other substances. Silver is unique. So one of silver's chemical properties is that it cannot be decomposed or separated into other stable, pure substances. All right, so that identifies silver as an element. And you probably already knew that silver was an element, and you could just look on your periodic table and see that too. But that's what I just said is how we're going to define an element in this class. Okay? So elements cannot be decomposed or separated into other stable, pure substances. Okay, that is what identifies them as elements. Now, the smallest unit particle of an element is an atom. Okay, so I'll write that down here. Let me change my color. The smallest meaning, so the smallest unit particle of an element is an atom, meaning if I had a lump of silver sitting somewhere and I were to zoom in and I could pluck out just one little silver atom, it'd be the smallest unit particle of the element, okay? One singular silver atom, all right? All the way down at the super, super small particulate level. Water here now is going to represent our second kind of pure substance, all right, which is a compound. Unlike silver, compounds like this water molecule can be decomposed into other pure substances or other substances in general. So, and then we'll talk about that. So any pure substance that can be decomposed by a chemical change into two or more pure substances is a compound. All right, so that's our definition of a compound for this class, okay? So definitely know those two definitions as you do the homework and you go through the class. Okay, so this is just a chart that really is there to help you and you can use for reference. Be sure to catch this distinction shown here. So on the left, this shows how you would separate an impure mixture, which is what we talked about at the end of the last video. And remember, we separate mixtures by physical means. So like magnetism with the iron and the sulfur example, like boiling point, separating the water from the salt, distillation, which might separate, the particulates, the larger particulates out of a liquid. Okay? And depending on the method and the sample that we're trying to separate, we could separate things into compounds or into elements, like in the sulfur and iron example. On the other hand, though, if we wanted to separate a compound over here, right, the only way to do that is by chemical means, okay? It's the only way you could separate it. So if I wanted to separate water, I would need to do a chemical reaction to do that. And that's something we're going to talk about in a later video. And through chemical means, I could separate those compounds into other compounds or into elements, okay? So that's the differences there. Impure mixtures are separated by physical means. Pure compounds are separated by chemical means, okay? So I'll say that again. Impure mixtures are separated by physical means. Compounds are separated by chemical means. All right. So there's at least 88 elements that occur naturally, and the name of the element is always a single word. That's something to keep in mind, okay? So if you're confused about names of elements later on, remember this. The name of an element is always a single word, like hydrogen, carbon, helium, cobalt, you name it, copper. The names of compounds are usually two words or compound words, okay? So like sodium chloride, calcium carbonate, those aren't elements, those are compounds, all right? So let me just turn my page here. So here's, that's just a key that we should know. Here's the major elements of the human body, okay? So these four elements, hydrogen, oxygen, carbon, and nitrogen, make up 99.3% of the atoms in our body. So that's just a fun little fact that you can share with people to impress them, or at trivia night, maybe that will come in handy and you'll win the day. No idea, but it's just quite amazing that most of our human body is just made up of four elements. So here's another example, right? These are just familiar objects that are composed of nearly pure elements. I'll let you kind of distinguish which elements make up what. This is some copper wire, maybe. At least it looks like it to me. So I'll let you go through and kind of discover what some of these items are made of on your own. It's pretty interesting, actually, or at least I think so, but I'm a chemist. So maybe you disagree, but many objects that we use every day are made of almost entirely pure elements. So how do we represent elements? Well, chemists represent elements with element symbols. So if you grab a periodic table, like this one, okay? This is what you're going to be using throughout the semester. And I believe the periodic table in your book should have a list of all the elements on the back of it. So you can use this as reference. It has the atomic symbol, or excuse me, the symbol of the element, its atomic number and atomic mass, which is something we're going to talk about later. But if I believe this is in your book, if it's not, you could definitely print one off the internet. Hold it this way, so don't worry. Oh, now it's upside down. Okay, I'll hold it this way. You probably can't see it anyway. So you don't need to necessarily memorize all the element names and symbols. That's not what I'm asking you to do. I'm really just trying to give you a brief introduction so you understand a little bit about what's going on with the periodic table as we move forward. So chemists represent elements with element symbols. So the first letter of the element written in uppercase is often its symbol. So obviously hydrogen, the first element, starts with the letter H. So its symbol is a capital H. No surprise there. Okay, there's other examples that we could find and that you could find on a periodic table. So for example, we could go to something like iodine, element symbol I. Oh man, it doesn't like when I write A's. I've discovered this. Carbon, element symbol C, right? Those are examples, just a few, right? 2 examples of elements that have the same, their element symbol is the first letter of their name. Okay, if the symbol of more than one element, all right, starts with the, begins with the same letter, excuse me, a second lowercase letter is added. Okay, so for example, we would have something like helium. element symbol is He. So it has the same beginning as hydrogen, but there's an extra lowercase letter added in the element. Okay. So again, just an example of that. And finally, the symbols of other elements derive from their Latin names. So the example there, would be like iron. Its symbol is Fe. All right. So if you're wondering why is iron symbol Fe instead of, Ir or something, it's because it derives from iron's Latin name. Okay. So again, not something you necessarily need to know and memorize and, commit to spending a bunch of resources and memorizing. Just know where some of these symbols come from. You'll be fine. Have a periodic table that lists them all. Okay. So shifting gears a little bit, let's move on. So as I change my page here, so the symbolic representation of the particles of a pure substance is known as its chemical formula. Okay, and this formula is a combination of the symbols of all the elements in a substance. So for example, we've already seen this in a previous video. This is H2O or water, and this is a model of it. And so what the chemical formula which is this guy, is showing is that that water has 2 hydrogens and 1 oxygen. Okay, it tells us the elements that are in the molecule of water. Okay, so this is water molecule. But it also tells us how much of each we have. And I think that's on a future slide, but it's pretty obvious, I think, here as well from the chemical formula. All right. So the formula of most elements is the same as the symbol of the elements. For example, sodium is just Na, helium is He. These are their symbols for the elements. However, other elements exist in nature as molecules, okay? And their formulas indicate the number of atoms of the elements in the molecule. In particular, these elements exist in molecules that contain 2 of each atom of the molecule, okay? So, for example, hydrogen and oxygen, if you were to find some in nature, would exist as H2 and O2, which means that there's 2 atoms of hydrogen bonded together. Or in oxygen's example, there's 2 atoms of oxygen bound together. And this is how they're found in nature. So when we write down their chemical formula for these elements, okay, we need to take this into account. And there's a list here of all the diatomic elements. Okay, hydrogen, nitrogen, oxygen, fluorine, iodine, chlorine, bromine. These are all the diatomic elements. So you can have this chart with you so that you know which elements exist in this. Their chemical formulas, I should say, are these diatomic 2 atoms bounded together. Excuse me, I'm a little tired tonight. So, and it's this kind of funny acronym over here on the right. It's, let me change my color here so you can see it. So you can remember it. Have no fear of ice cold beer. All right, so hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, bromine. All right, so that's all the elements that exist as diatomic molecules. And that's the correct chemical formula for these elements. Okay, so again, you can have this chart for reference. You don't necessarily need to memorize all the elements that do this, but I think you can with the acronym especially. So finally, I already said this, but the formulas of compounds also include subscripts that show the number of atoms of each element in the formula. And we're going to get plenty of practice with this later in the semester. This is just a brief introduction. For example, we already said that hydrogen, or I keep saying hydrogen. We already said that water, this formula is telling me I have 2 hydrogens and 1 oxygen. We can see that here in the model. Over here for another molecule here, NH3, okay, which is ammonia, we'll see that here, well, it's saying I have 1 nitrogen, which is here, and 3, oh man, that's bad. 3 hydrogen, okay? So not only is it telling you the elements that you have, but again, it's telling you how many of each of that element's atoms you have in the molecule, okay? So 3 hydrogen atoms, one nitrogen atom. Okay, so if you have any questions on that, feel free to rewind the video again or reach out to me. I'd be happy to answer any questions. So, chemical compounds now. So we've been using water a lot as an example, and this is something to keep in mind here, that the properties of a compound are different from the properties of the elements that make up the compound. So here's just a list of kind of the state of water, hydrogen, and oxygen at room temperature. So water is a liquid at room temperature, as shown here on the right? It's a liquid, whereas hydrogen and oxygen are colorless gases at room temperature. And you can see the differences in their melting point and boiling point. So again, this is saying that the properties of a compound are quite different than the properties of the elements that make up that compound in most cases. So just be aware of that. All right, so coming to a close here pretty soon. This is a summary of the classification systems for matter that we've been talking about in the last few videos. I'm not going to go over this at all. This is for your reference. You can have it as you do the homework, and you could print this out and have it with you. And this will help you to distinguish between the different types of matter, pure substances, mixtures, elements, all sorts of things. So have this for your reference. Okay, so finally, here's an example problem that we'll do together. Which of the following are compounds and which are elements? So I'll actually ask you to pause the video, try to figure this out on your own, and then we'll do it together. Okay, so I'm assuming you paused the video and you were able to answer these questions. So the first one here, well, there's 2 different types of elements here. There's sodium and there's sulfur in this compound, and you could have checked that on your periodic table, and I hope you did. So this is a compound. Okay. What do we think about this one? Well, there's 2 bromine atoms here, but remember, this is one of those diatomic elements, okay? So this is an element. So potassium hydroxide, okay? Without knowing what this is 2 words. Elements are always 1 word. So this is a compound. And then fluorine, this is an element. Okay, so again, that's just a brief overview of elements and compounds. Please let me know if you have any questions. And I think in the next video, we're talking about the electrical character of matter.